Let's continue with example number 3. On example number 3, we are dealing with division. And as we learned back on elementary, to be able to divide fractions, if we have 1 over 10 divided by 6 over 15, we are going to flip this and make it to a multiplication. So we're going to change the division to a multiplication by taking the reciprocal of the second fraction. So instead of 6 over 15, we have 15 over 6. And we can just go and factor the 10 will be 2 times 5, the 15 will be 5 times 3, the 6 will be 2 times 3. And now we can go and cancel the 5s, we can cancel the 3s. So we just have a 1 on top, and 2 times 2 will be 4, and this will be our final answer. So using the same process, the first thing that we're going to do, we're going to go and change this division to a multiplication. So the first fraction will always stay the same. You know, let me go and rewrite. I recognize that this should be written first, correct? Just like we had on the previous example above. That should be a negative 4x and that plus 8. I'm going to change that division to a multiplication, and I need to flip it. So this will be x squared plus x minus 6. Denominator will be x squared plus 3x. Now I can go and factor. Now we have a problem just like we had on example number 2, where we can factor out each of those polynomials. 3x, nothing to factor out, so we just have a 3 and an x. Remember, it's 3 times x. We need to be able to factor out this, so take out the common factor. Is there a number that divides 4 that also divides 8? 4. Because this is a negative 4, remember we want to take out a negative 4. If the first number is negative, you want to take out a negative number. What do I need to multiply negative 4 to get negative 4x? X. Negative 4 times what is positive 8? Negative 2. Let's go and factor the top. So first, take out the common factor. Self. Is there a number that divides 1, 1, and 6? No. Do they all have an x? No. So nothing I can take out. I can just go and do my double parenthesis. Factors of x squared will be x and x. Factors of 6 are 6 and 1, 3 and 2. I need to end up with a 1, so I'm going to use my 3 and my 2. Positive 1, so I'm going to make that positive, that negative. From the denominator, first we want to take out a common term. Common factor, is there a number that divides 1 and 3? No. Do they both have an x? Yes. So I can go and take out an x. What do I need to multiply x to get x squared? X times what is positive 3x? So it will be positive 3. And now I can just go and cancel my common factors. X minus 2, x plus 3. And I can go and cancel an x because this is a factor by itself. There's no plus or minus, nothing adding or subtracting. And same thing here. This, the 3 and the x are multiplied. Those are factors. So I can go and cancel the x with the x. So I'm going to have 3 over negative 4. Or we can just, like we discussed before, we can place the negative in the middle. So it'll be negative 3/4. If the negative is on top, you can actually do the same thing. You can just place it in between the fraction. Let's continue with letter B. On letter B, we also have a division. So go and see if you can do it by yourself. Go and pause it, try it by yourself, see what you get, and we can compare answers. Great. So the first thing I'm going to do, I'm going to go and change my division to a multiplication by flipping the second fraction. The first one will stay exactly the same. It will be 2x squared plus 5x minus 3 over 4x to the third plus 12x squared multiplied by, and I'm going to flip this, 12x squared over. Now, I noticed that I need to be able to rewrite this, correct? That should be first. So that should be a negative 2x plus 1. Now, excuse me. Many of you guys are going to be tempted to do this on the test. I say, oh, I can cancel the 12x squared. You cannot cancel the 12x squared because there's a plus in here. This is a whole polynomial. It's not a factor. The 12 is not a factor. It's adding. So do not cancel that out. Let's go and start with the numerator. This polynomial. So first, take out a common factor. Ask yourself, self, is there a number that divides 2, 5, and 3? No. Do they all have an x? No. So I can just go use my double parenthesis to factor. Factors of 2x squared will be 2x times x. Factors of 3 are 1 and 3. Well, I use my 1 here, my 3 here, so that makes it 6. I know they need to have different signs because that's a negative. And so that'll be 6, and minus 1 is 5. I'm going to make this a positive, that's a negative. Now, I want to be able to continue factor. So first, let's take out the common term. Is there a number that divides 4 and 12? Yes, I can take out 4. Remember, you want to take out the biggest number. Not 2, but just the biggest number will be 4. Do they both have an x? Yes. They actually both have x squared. So I'm going to take out x squared. What do I need to multiply 4x squared to get 4x to the third? X. 4x squared times what is 12x? 4x squared times what is 12x squared? Positive 3. Times. It'll be 12x squared over. Remember, nothing to take out from the, nothing to factor from here. So let's continue with this. A number that divides 1 and 2? No. But because do they both have an x? No. But because this is a negative, I want to take out a negative 1. So I can make that positive. Negative 1 times y is negative 2x, 2x. Negative 1 times y is positive 1, negative 1. Now I can go and cancel my common factors. 2x minus 1 and 2x minus 1. X plus 3 and x plus 3. Now this is a factor and this is also, there's nothing adding or subtracting, so I can cancel. I can rewrite this as, because I want to cancel with the 4x squared, I can rewrite it as 3 multiplied by 4x squared. Right, this is the same thing. And now I can go ahead and cancel the 4x squared and the 4x squared. So I just have 3 and a negative 1, 3 over negative 1. I can place my negative here, or I'll just 3 divided by negative 1 is negative 3. And that'll be my answer. Let's continue with the last example, example number 4. On example number 4, we have a easier problem. Perform the integrated operations. If you guys notice, we just have one-term polynomials or monomials that are multiplying. So whenever you only have one term, we can just multiply across. So we have a 3. How many x's do we have? 2. How many y's? 3. A 6. How many x's do we have? 4. Now we can go and simplify. Let's go and reduce our fraction. One number divides 3, that also divides 6. Let's divide by 3, so it gives me 1/2. How many x's cancel? 2. So I end up with 2 on the bottom. And we just have y to the third. For letter B, we can go and change the division to a multiplication. So you want to do that first. The first fraction will stay exactly the same. We're going to change the division to multiplication by flipping the second fraction. Now we can go and multiply across. We have 6. How many y's on top? 2. We have 4. How many y's on the bottom? 7. And we can reduce. So one number divides 6, also divides 4. 2. So I can divide by 2. How many y's cancel? 2 of them cancel. We have 5 left over on the denominator. So this will conclude the lesson for today. Please email me if you have any questions. Thanks for watching and have a great day.